For number 16, we have an inequality with absolute value. We want to get the absolute value part alone to start with, so divide both sides by 4. You'll get to here. And then to remove the absolute value bars, split it into two equations. Make sure you pay attention to the sign and the inequality for your two equations. And then solve them both. For this first one, subtract 5 from both sides, divide both sides by 2, and so you get x needs to be greater than or equal to 0. Or in your second equation, subtract 5 from both sides, divide by 2. X can be less than or equal to negative 5. So if x meets either one of these conditions, if you plug it in here, it'll be true. And in interval notation, it looks like this. Make sure you use the brackets because we have greater than or equal to 0, less than or equal to negative 5. For number 17, an absolute value equation. You want to get that part alone, so subtract 10 from both sides. You'll get to here. And then to remove the absolute value bars, you split it into two equations. One with the positive, one with the negative. And so working down this first one, subtract 8 from both sides. And now divide both sides by 7. So there's one option for B. And the other one, subtract 8 from both sides. And divide both sides by 7. And here's the other option for B. So B can be either one of those values, and it'll make this equation true. For number 18, we have two functions. We're going to add them together. Like with any fractions, they need to have common denominators to add. And so this has the denominator of 4. This one has a 2. The least common multiple those would both go into would be the number 4. So you can leave this one as is and change this to a denominator of 4. So multiply on top and bottom by 2. So when you change that, everything on top gets doubled, everything on bottom gets doubled. Now you can add, and the bottom stays the same, and then combine that top part, you would get this. Number 19, we're solving for the letter A, which means get A alone on one side. So to start with, you'd want to add 7y to both sides. That will get you here. And then the last thing you need to do is divide both sides by B, and that will get you to the answer. For number 20, trying to find all values where you plug it in and get a 0 back. So this is what we're trying to solve. One way to do that is by factoring. And so here's what it would factor down to. And so you can see if you plug a negative 4 in here, it would make this true, or if you plugged a positive 3, it would also make this true. So those are the two solutions. For number 21, we have an investment scenario. And the first part of the problem says to complete the ordered pairs for the given data. And so for this first point, we have an x value of 0. And x is the number of years since 2005. So if it's been 0 years, it means it's still 2005. So the y value, the amount of the investment, is how much he had in 2005. And for the second point, we have a y value of 40,000. And in the problem that's given here, that he has 40,000 in 2010. Well, the x value should be the number of years since 2005, and 2010 is 5 years later. So the x value would be 5 years later, he has 40,000. For part B, we're finding a function that goes through the 2 points. So we have 2 points here. Let's find the slope of a line that would go through those. Subtract the y values on top and subtract the x values on bottom. You get 5,000. The investment's changed by $5,000. And on bottom you get a 5. The number of years, it's been 5 years. So if you're making $5,000 in 5 years, that reduces to $1,000 per year. And so that's your slope. Slope of a line between those 2 points is 1,000. So y equals mx plus b. Y equals 1,000x plus, and then b is the y-intercept, the value when x equals 0. So we have that already. Y equals mx plus b. We get that for our function. Interpret the slope in the context of this problem. The slope is growth per year, how much your money goes up each year. And then part D, if it continues to grow at the same rate, how much is it going to have in 2020? So just use your formula here and plug in the correct value for x. 2020 is 15 years later, so put a 15 in and then solve that down. We'll have $50,000.